started. And as part of getting started, remember, one of the things that we could address would be looking at the class where your questions are, and potentially also homework. I need it back in the class. So I decided, based off questions that I was seeing in the tutoring center, that we should go through and look at some questions from the homework and use them as kind of examples to leverage some information. So, first and foremost, I want to address something that's really, really important as far as the online homework goes. Everybody sees these boxes and starts to go, okay, I'm going to start putting things into these. I'm going to, if I could scroll, apparently I can't scroll because I zoomed too far in. Really? I'm going to go through and start, dropping numbers into these boxes because, I can. Okay? Right out of the gate, I'm going to tell you, you're doing this wrong. Active is not grading you based off of when you put something into the box. What it's grading you on is your final work correct? Which means don't start trying to get the answer by putting things into the box. Where should you start your process? Pencil and paper. Once you have a pencil and paper thing written down, you can now transfer that pencil and paper thing into the boxes within Active to see if you were correct or not. That is the point of Active. Part of it is that it's also going to go through, and we'll show it in a second, go through and actually show some of your processing as you would navigate it, but our start needs to be pencil and paper first. And as an added bonus with doing it in pencil and paper, what else do you get other than carpal tunnel? It completes your paper homework. Okay, that is now a question for your paper homework. So you get paper homework partially done and active done all at the exact same time. Okay, that's the point of the paper homework, is to provide you the incentive to be writing these things out, pencil and paper. Okay? So, if we're going to start this off, okay, and will be painful because I'm the one talking about it, of course, I'm going to be the one saying where we should start. So, where should we start? Not wherever we want. Come on. I'm more prescriptive than that. Or maybe what you said was, what do you want? Is that what you said?
Yes.
Okay. What do we want? So we want to read through the question and said, what does it want us to solve for? Okay. Moles is an excellent place to start. I'm going to argue you're wrong. It's not asking us to start finding moles. What is it asking us to start finding?
The quantity of moles.
Quantity is now the numerical value in front of moles. The moles of calcium chloride. Okay. In this particular question, identifying that substance of calcium chloride is not going to be critical. But as we will see very swiftly, even in today's lecture, we need to start including and getting used to specifying the substance. This is why when we go all the way back to your very first lab, and the background information of the lab class says that whenever you write down a number, you provide the number, you provide the measurement unit, and you provide the substance. The example we used in class, I'm a 6. Well, what the hell does that mean? Okay. If we go through and say, I'm 6 feet, that changes in interpretation, right? Okay. What was the substance when we say I'm 6 feet? You're assuming me. No, I'm saying I have a 6 foot long arm. Does that change your interpretation? Drastically changes the interpretation from being, yeah, Mike's probably about 6 feet, to there's no way in hell he has a 6 foot long arm. He must be spotty in the head. Okay? So including the number, the measurement unit, and the substance becomes very critical to our ability to interpret the real world, which is why when you navigate a calculation, you must use all of those pieces of information. Okay? Again, they aren't always critical. Okay? This is one where it's not critical, but the idea is habits of mind so that you continue to do it when it is critical. It's not a, oh, now I have to do it. You're already doing it. Kind of, sort of? Okay. So that's what I want to solve for. What's the next step? What are we given? Okay. This being a straight line kind of system makes it seem a little bit weird to create a list of what we're given, but we could go through and write 4.21 times 10 to the 23rd. Okay, and then we encounter this weird thing, formula units. What the hell's a formula unit? Anybody know? For the record, it took me a long time to figure it out too. I was like, why are we using formula units? Okay, and I immediately was like, they're just being stupid and they want to call it formula units when they're actually talking about molecules. So we're talking about molecules of calcium chloride. So we'll take a brief moment and say they aren't being stupid, they're actually being technically correct. When we look at the substance of calcium chloride, it's an ionic compound, and if we look at the overall structure if I had a whole bunch of calcium chlorides put together, there is no single unit that I could separate from anything else. If I go through and look at calcium chloride, I'm going to see this repeating pattern, and all of the connections between these are all identical. So there's no difference in strength between those connections, which means to get to calcium chloride as a section, I'm kind of arbitrarily creating its own unit. Okay? I'm creating a formula unit, if I will. But if I switch to a compound like water, and I look at water in a solid, what's going to end up happening is I'll have a bunch of water molecules that will be really close to each other. But now when I go through and look at the connections between those water molecules, they're different. This connection, connecting those two water molecules together, is different than the connection connecting the oxygen to the hydrogen. How is it different? Okay. And if you're struggling to figure out how and why it's different, that's because we never talked about it. Okay? Or rather, we haven't talked about it officially yet. Okay? The difference there is that solid line represents a chemical bond. What does that dashed line represent? Not a bond. Right? That's where you're at this point. Those are now different things, which means if I go through, remember I need it by the end of that, or end of today. If I go through and now look at that structure, I could start to remove all the not a bond things and remove my patterns, and I would end up with an actual molecule where they're connected to each other. That's why we call things molecules versus formula units. It's a reference back to the type of connectivity within that individual quote-unquote molecule. Okay, since it's ionic, we're calling it a formula unit, not a molecule. What do you want to call it? Stupid. Right? Agree with you too there. Okay. I prefer to call it as a molecule because that's at least the most straightforward and continuous thought. Okay? It is technically correct to call it a formula unit. It's adding proper language in a situation that only muddies the water. I think it's a bad idea. Okay? So if you see formula unit and immediately want to write molecule, go for it. Absolutely fair game. Okay? You just have to realize that they are roughly equivalent. How do you feel about writing out the word molecules? Okay, some are like, oh, that's way too painful. I don't want to write out molecule. I wish I had a shorthand for it. Okay, well, the shorthand for it would just be start truncating it all the way down. We can't use M because M is meters. Okay, we could also encounter M being used as mass, which also creates problems. M already has a bunch of different things associated with it, so we want to come up with something else. So we could use MO. Can't use MO because
Missouri?
Sure, we can go with Missouri. Molybdenum, it's an element on our periodic table. MO in a different class also means molecular orbitals. Okay, so MO is used. So then we could try and use MOL. Oh, that's perfect. That must be where mole comes from. No, it doesn't. Okay, and that becomes one of the other secondary problems. Because when we talk about moles, it's not molecules. Mole is an entirely new unit system. Okay? So this is why when it comes to an abbreviation, what you will see me use for molecules is MLCS, which is a whole bunch of letters, but at least it's not MOL. Because if it's MOL, that's confusing. Kind of makes sense? You don't like that, write molecules. That's fine. Or formula units, if you really wanted to. So far, so good? Cool. If that's our only given piece of information, we have to go back to our whole setup down below, okay, our calculation, and we have to figure out how to put stuff in to make this equal. I don't know why I drew all those lines. Okay. Well, there are other problems. We picked one of the pieces of given information that closest matched to what we were trying to get with. At this point, we only have one piece of given information, which means that's what we're going to use. Okay? So now the next question becomes, where should we place it? Should I place that in the numerator or the denominator? Okay. And this becomes a fun dilemma of a question. Okay? Remember Monday I got all cranky and yelling at people? Okay? Because I asked and they're like, I didn't know why. Okay? We have a reason why to place it. I'm not just going to place it in the numerator because, well, it's the only single thing. What is the substance I'm solving for? Calcium chloride. Where is that substance located in what I want? In the numerator. So I go back to my given piece of information. Is that the same substance? Yeah. So where should it show up? In the numerator. So that it matches closest to my answer. Okay? It's not the exact same thing, but it's at least placing me in the location that I need for my final answer. So I'll drop this in. Can I write MLCS? All I needed was one no. Molecules of calcium chloride, perfectly acceptable. We can then also include our number associated with it. This makes our line absurdly long. I need to write smaller. 2, 1 times 10 to the 23rd. What shows up in the denominator? 1. Same process. Are those equal? Is molecules of calcium chloride the same thing as moles of calcium chloride? Nope, they are different. Since they are different, I'm going to have to do something extra. That something extra has to get included in another piece of information. That extra piece of information now is your choice on where to focus. Do you focus on what you don't want, or do you focus on what you want? What you want. Okay. What I want is moles of calcium chloride. Where do I want it? Do I want that to appear in my numerator or the denominator? Look at the answer. Where does it show up? In the numerator, which means in my work, where does it need to show up? In the numerator. I know I have to do a conversion. What do I want to relate the moles of calcium chloride to? Before we get excited and shout out answers, I'll interrupt and say, I could convert the moles of calcium chloride to grams of calcium chloride. I could convert them to moles of calcium. I can convert it to moles of chloride. So there's lots of things I could convert to. What do I want to convert it to? Okay. And this again becomes this question of, well, I don't know what I want. Well, go back to your work. Yes, I want to bring in moles of calcium chloride. What else do I want? To get rid of molecules of calcium chloride. So what I'm going to start is say, I want molecules. Already told I can't do that. As my wife knows, you have to keep telling me things. Okay? I want this conversion. Just because I want it doesn't mean it exists. Okay? But that's what I want. So now I have to ask, is that a conversion factor that exists? Okay? And if you're early on through this unit, you may be like, well, I don't know yet. That's okay. That's where you need practice, and you would go and try and find all the potential conversion factors that are out there and try and figure out, does that conversion factor exist? For the people that have advanced a little bit further through the unit and watched our lecture videos, does this conversion factor exist? Yeah. This conversion factor does exist. In fact, it exists so importantly that we actually give it a name. Oh my God. God. Did I actually get it right? I think I got it right. It's Avogadro's number. Okay? Are you required to know this number?
Yes.
Yes and no. We'll come back to the no later. Okay? But yes, you're required to know this conversion. Okay? What is this conversion? 6.022 times 10 to the 23rd. And since that's the number I've memorized, I will write 6.022 times 10 to the 23rd. And I would be wrong. Okay? Because it's not just the number, it's associating with the proper unit. It's 6.022 times 10 to the 23rd things is equal to 1 mole of things. A molecule is a thing. Right? And if we want to get real nasty with this conversion and really explode our unit, this isn't moles of calcium chloride. This is of molecules of calcium chloride. That's actually what that unit is. Okay? And the only reason we're bringing in the molecule unit is because of Avogadro's number. Like, if we just said 6.022 calcium chlorides equals 1 mole calcium chlorides, would that make sense? Technically it does. What is calcium chloride? A molecule. So why am I saying molecule? To add an extra unit so that we see the measurement unit in that. It's to add clarity to our conversion system. That's it. Okay? I would argue you should include it there because when you drop it off, you start to make mistakes with later conversions. Right? So if we imply it within that moles system, we get 1 mole is 6.022 times 10 to the 23rd molecules of calcium chloride. What happens with our units? The molecules of calcium chloride cancel out. Lovely. That's exactly what I wanted to happen. What's left over? Moles of calcium chloride. What was I being asked to solve for? Moles of calcium chloride. So what do I have to do? 4.21 times 10 to the 23rd and divide by 6.022 times 10 to the 23rd. Okay? This would be a good one if you had a calculator to go through and calculate. Okay? Because I would not be surprised if a significant portion of the class, when you went through to calculate this, got 6.6 times 10 to the 46th moles. Okay. Which, for the record, is wrong. Okay. And what's happening in that scenario is that you're not taking advantage of parentheses to ensure that this division with that 10 to the negative 23 is happening in the denominator. Okay. Does that make sense? Okay. If that 10 to the 23 is in the denominator and that 10 to the 23 is in the numerator, what should they do? They should cancel, which means really all I'm doing is 4.2 divided by 6. 0.022. Okay. Which is ballpark 2/3, which I'm saying is about 6. Right? Powers of 10, but it would be 0.6 something. Kind of makes sense? Right? At this point, I now have work. Right? I have work and I have an answer. So what I can now do, because I've written out that work, and I've written it in a place that is permanent and doesn't get deleted when I go boop, I would now go back to active and put that information in. Okay? You'll note that active has kind of swapped the order around. If you don't like that order, change it. It ultimately doesn't matter. Okay? That's going to come down to your perspective. But we can now go through, I have to zoom out a little bit so I can actually see all the things. We started where we had formula units, right? What was the number? 421, 10 to the 21st. I already forgot all the work that we did. Okay, formula, ooh, cool, it shows, look, they canceled, right? My work showed that too, that they canceled. Now active is showing that neat too. And what did I want on top? I wanted the moles of calcium chloride. Okay. I remembered that 1 mole was 6.022 times 10 to the 23rd. And I go, oh, submit. There's no submit here because it's the instructor version. But we'd be wrong because you didn't actually say what the answer was. So that's where you go and say, oh, well, I want the answer. Would I click? Yeah, there it is. Click. It needs to be moles of calcium chloride. I said it was roughly, my ballpark, that. Now I click submit. And it says, zippity-doo-dah, I'm a genius. Or you should say that, right? When you get it right. Celebrate those small victories. Does that make sense? Okay. I picked this particular question because I thought it did something else. So let's do the something else. Okay, because that question was too easy, right? Don't you hate it? Instructor goes through, sets up a question. Let's solve this question together, and then they ask you to solve something wicked hard afterwards. Okay, so let's switch it up. I don't want moles. I want the quantity in grams. And because we hate it when instructors go through and they say, well, now that you know how to do this simple thing, you should be able to do this super advanced thing. So, do this super advanced thing. Whoop, don't resume recording. Okay, so if you're coming back and watching the video, all of a sudden all this work appeared on the screen. So let's start to talk through the work. We're going to do kind of ignore the stuff happening behind, ignore the stuff at the bottom for the moment. Just focus on the stuff at top. Okay? So we want grams of calcium chloride. We were given molecules of calcium chloride. Okay? We know the molecules of calcium chloride should be canceled. So we need to place that in denominator. What do we want to appear? Grams of calcium chloride. So, just go all the way in, all in. Boom, single conversion factor. Does that conversion factor exist? Okay. And this is what this unit is about. This unit isn't about how do I do all these conversions. What this unit is does this conversion factor exist? That's all we're doing. Because you already learned how to do conversions in the last unit. Right? So you now have to be referencing all the information that's being thrown at you where we're showing how to use those conversion factors, but you have to know, does it exist? Okay? Grams to molecules. Okay? Immediate reflex that students will tend to pull from is, well, does it exist? Google, does this exist? Google's going to fucking give you everything. Right? That doesn't mean it actually exists. That means Google is running a calculation to determine what that conversion factor is. Okay? For instance, is there a conversion factor from inches into kilometers? I don't know. Inches into feet, and then feet into miles, and miles into kilometers. Right? So you'd have to go all those conversions. You ask Google, yeah, there absolutely is one. What did Google just do? All of those conversions at once and put it into one big thing for you. Okay? So you have to be careful referencing, does this conversion factor exist to the internet? What you should be doing is referencing it back to the notes of the class. Okay? And if you don't like the notes of the class, that's fine too. You can go to the thing that begins with tutoring center. Do you have the green sheet, the mole wheel, handy? Okay. The tutoring center has this thing that they call the mole wheel. I absolutely freaking hate it. And that is recorded. Okay? It's not necessarily bad, but I think what it does is remove the dimensional analysis process. Okay? And maybe it's not green, maybe it's blue. Oh, it's blue. Okay. She's got one up there if you got it. Is that it? There it is. Cool. They've got the mole wheel. People watching at home, tough. Okay, that's why you come to class. Okay, that's the mole wheel, and they show, oh, this is how you do all these conversions. It just looks like a freaking headache to me. It looks like a giant Trojan horse with spears and stabby things. I don't want spears and stabby things in my brain. Okay? Does it help? It helps some people. So yeah, go ahead and use that if you feel that's necessary. But that provides all the kind of conversion factors that you could use and navigate to get through this question. Right? But ultimately, what you're going to be responsible for is looking at this and being like, does that conversion factor exist? No. Why not? Why do I not have a gram value for a molecule?
They're all different.
I've got gram values for moles. We'll come back to that in a second.
Molecules are so small.
Bingo! Molecules are insanely small. So if I looked for the gram value for a single molecule, we're looking at something insanely tiny. This is 10 to the negative 22nd, 23rd. Okay, grams. That's an insanely small number. Okay? That's not going to be an easy one to write or present or format onto a periodic table. Okay? So that's why that conversion factor isn't readily accessible. Okay? Which sets us up with the next question. If that doesn't exist, we have to find a conversion factor that does exist. And we have to look at this and decide, where do I want to focus? Do I want to focus on bringing grams in, or do I want to focus on getting molecules out? Okay? A lot of people will go through and say molecules out, which is perfectly acceptable. Okay? There is no problem with that. There's also no problem with trying to bring grams in. Okay? Either case, you're going to be phrased or centered on the same question. What do you want to convert your chosen unit to? Okay? I've got molecules of calcium chloride. What do I want to convert them to? Okay, grams. We just tried that and it failed. Okay, moles. Why moles? Okay. Why moles? Because I know it exists. That's fair. Okay. I love that idea. That's the bottom case. So what I'm going to do is say, I'm a little spotty in the head. I'm not going to go. I'm not going to go to moles because we've already done that. We've seen that. We know it works. We could do it. What I'm going to do is something wild. In fact, I would argue so wild it's dumb. Okay? I'm going to convert molecules into AMUs. You can make the face. That's fine. I get it. Okay? Because it's a silly conversion to go through and do, but it works. AMUs of calcium chloride. Okay? Is there a conversion factor that relates AMUs to molecules? Yeah. Okay? And depending on how much you remember from the very first unit, okay, maybe you even remember where to find it. I would actually kind of hope you don't know where to find it because I don't want you referencing it as AMUs per molecule. Okay? We're looking at a mass for a single molecule. That mass to amount, a mass to a count, is found on the periodic table. That is the mass number under each of our elements. So if I have calcium chloride, I can look up the mass for calcium, 40.08, and I can look up the mass for chloride, 35.45. There's two of them, so 35.45 plus 35.45 plus 40.08 gets me 110. That takes all the fun out of it if you say the number.
Sorry.
I was trying to be like, look at how smart I am because I did the math in my head. Okay? And we now have that number. Okay? Does that get me closer to my answer? Okay? And this becomes a fun one. A lot of people will be like, well, no, because you need to go to moles. Well, hold our breath. Don't hold your breath because I take too long. Molecules of calcium chloride cancel. Okay? Did I actually get closer? What was AMU a measure of? Mass. What is grams a measure of? Mass. Yeah, I got closer. I'm now in a mass unit. Okay, what has to happen? I need the AMU to cancel out. Okay, technically the AMU of calcium chloride. What do I want to appear? The grams of calcium chloride. Does the conversion factor between grams and AMU exist? Yeah. Is it one you memorized? Probably not. Is it one you should memorize? Technically, you already did, believe it or not, even though the number's not going to look familiar. 1.661 times 10 to the negative 24th grams is 1 AMU. What happens? AMUs cancel. Plug it into the calculator, I'm going to get grams of calcium chloride. Okay? Did anybody solve it that way? Nobody? Oh, you did? Oh, hell yeah. Really?
I did stuff wrong. Because grams equals...
I did up there.
Yeah.
Oh, son of a bitch, good job. Oh, yeah. I didn't think anybody would do that. Okay. How did you all solve it? Well, you said, I want to do molecules to moles, right? Okay, so we look at those numbers. 6.022 times 10 to the 23rd molecules, 1 mole, right? All that. Okay. Units, the molecules, calcium chloride cancel. I need moles of calcium chloride to cancel. And what do I want to bring in? Grams of calcium chloride. Does the conversion factor between grams and moles exist? Yes. That's the number on the periodic table. That was 100 and... Alright, shit, man.
110.
I was trying to be all fancy and remember numbers, and I can't even keep them in my head. They're on the screen. 110.984 grams of calcium chloride is equal to 1 mole of calcium chloride. What happens with the calculation? The moles of calcium chloride cancel, and I get grams of calcium chloride. Isn't that what I wanted? Did I run the same calculation? I would bet most people are going to be like, nope, you didn't. Except when you run those calculations, guess what you get at the answer? The exact same value. Which means, yes, indeed, we did do the exact same calculations. What the hell? Take that middle thing, if you got a calculator handy, and do 1 divided by the quantity with your parentheses, 6.022 times 10 to the 23rd. I mean, it looks like people might be doing it, but I could be wrong. Oh, you did it. You got to actually have a calculator. Yeah, what number do you get?
1.660577 to the negative 24.
You mean 1.661 times 10 to the negative 24th? Yeah. Okay. Avogadro's number is created so that you don't ever have to flip and use it. Avogadro's number is the direct inverse of the gram to AMU conversion. Okay? So when I do the multiplication of that gram to AMU versus the division of the mole to molecule conversion, those numerically come out to be the same. Both end at the exact same spot. Okay? And if we really push on what I said, the whole point of Avogadro's number is so that I don't have to use that number. Didn't I just frickin' use it? Yeah. Well, Mike, you're an idiot, because why are we using it? It's literally being used. Okay? The only reason it gets used in questions like this, we want to configure out the grams of some absurd number of molecules. Okay? How about let's do a test? Let's count to 4.21 times 10 to the 23rd. So 1, 2, 3, 4, 5, 6, up to that number. Do you know how long that's going to take you? I believe multiple lifetimes. You will die before you reach counting that number. then why the hell would we ever run this conversion? To prove that you know how to do conversions. That's it. Okay? This is set up as a theoretical system for you to run through these calculations to prove that you know how to deal with the conversions, okay? Particularly conversions of powers of 10. Because powers of 10 conversions are tricky to deal with, particularly when we're dividing by them, and we tend to screw up the order of operations. So we have a conversion process now that allows us to test, do you actually know how to set up a proper conversion and the mathematical prowess to enter it into the calculator correctly? Okay? I would argue that's rude. Okay? Yeah, I completely agree with you, it is. Okay? But is it a necessary skill? It is a necessary skill in chemistry because if you move through more chemistry, you will run calculations that are dealing with powers of 10. They're not going to be Avogadro's number, but they are going to be powers of 10 calculations where you're dividing or multiplying or squaring. So we have to set you up with the skills to allow you to navigate further along. But if you're a student that this is your only Chem 130 class you're going to take, you're like, well, then I didn't need it. Why are you teaching me? This class covers everybody. We get the people that are going to go all the way through to become actual chemists. We've got people that are done after this class. We have to ensure that everybody has that content moving out. Sorry. Okay? And the important part behind this is, do you have the process to solve? That's it. Kind of, sort of? What do you think? Is that depressing? Exciting? Does silence mean it's depressing? Okay. So how would we expect to actually manipulate these things? Okay. And actually, before I even do that, if we were dealing with active, okay, active may funnel you out of one of these as a potential option because you're looking at dropping in things that they're given to you. If they don't give you the 1.661 times 10 to the negative 24th, you have to use Avogadro's number. Okay? And I would argue the Avogadro's number calculation is much more prevalent, and you'll see that everywhere. Okay? But again, it's not a big deal. It's running the same thing. They're just different unit systems. Kind of, sort of? Okay. So, if you took great notes, what do we have right up here? Nothing. This is the answer to what this, whatever online homework thing is. Like, ta-da, there it is. Ta-da, did you get notes? If you didn't get notes, sorry. Take a picture, fast. Oh, that's really annoying. Right? This is how we would typically look at chemistry questions. Because if we're going to go through and run a chemical reaction, okay, what we're going to set up is we're going to measure those things out. To measure them out, we're going to mass them. Okay, that's how we measure things. Why do we not count the number of particles? Okay, 2 answers. There's too many and they're too tiny. Okay, we don't have an ability to be able to count the number of atoms in it. So that means when we're running a chemical reaction, what we're going to be doing is massing those things. Okay, typically we would mass for solids. For liquids, we're not going to do mass typically. We would do liters. We would do volume. For gases, those are probably going to convert out into pressure units. Okay, you're like, well, we haven't talked about pressure units. I know, that's later in this unit. Okay? So we're trying to address all of the possible ways that we can deal with these systems. So if we're looking at this, I'm going to take ammonia, NH3, I'm going to react it with oxygen, and it's going to make nitrogen oxide. Okay? And I want to try and figure out how much nitrogen oxide I should expect to form. Okay? This is more in line with what we would be expected to do as chemists. And within this, guess how many times Avogadro's number is going to show up? None. Doesn't appear. Because it's not relevant to our standard conversions. It's only relevant when we're dealing with, why did we invent this goofy-ass number? We invented it so that I could use the periodic table more appropriately. It makes the periodic table masses molar masses. Mass per mole. That's awesome. Okay? So if we now look at this, how do we go through and figure this out? Okay, it says we're going to start with some mass of ammonia, 25.0 grams, and some mass of oxygen. Okay? Primary reason why I'm picking this question is I overheard a comment that I hope was totally not heard correctly, but I heard a comment that when you look at this reaction, the only thing you care about is that that number in front is bigger, and therefore that's everything your answer is, which is a complete and utter load of trash. Okay? How do I know? Well, we've got a simple explanation behind this. Okay? If I look at the numbers between 0 and 10, let's do 1 and 10. If I pick any two numbers, they'll add up to 10. You're already shaking your head? Really? 9 and 1. 8 and 2. Why am I wrong?
Because 2 and 3 equal 5.
Oh, son of a... Okay. The example of saying, well, which one's the biggest number is only relevant in a 50-50 scenario. So they're like, well, I've been right. You've been right half the time. You just haven't tested enough to figure out that your process for determining that was utter bullshit. Okay? And that's the addition to get to 10. It's the exact same analogy. Okay? So we have to be real careful with how we approach this question and how other people are approaching it to ensure that you're getting to a proper answer for a proper reason. Okay? What is that? Conversions. Lots of conversions. Okay, so let's take a step back because nobody likes NH3. It stinks. We like oxygen. Okay, but everybody likes cheese sandwiches. Right? And because our sandwich is, I don't know, sandwich bread's been out a little bit, it's purple bread. Okay? And we get our cheese, nice little orange thing. So if we're going to build a sandwich, right, what do I need? Well, I need my slice of cheese, and then I would need what? 2 pieces of bread. Keeping it real simple. I don't know why we had another floating piece of cheese. Okay. This is the recipe. This is the chemical equation for how we would build our sandwich. Okay. If we push back a little bit on this, okay, this is the minimum to do it. But if I go into the store, am I going to buy 2 slices of bread? No. What am I going to buy? A loaf of bread. And that loaf of bread, because someone's obnoxious, has 15 slices within it. And am I going to be able to buy a single slice of cheese? No. I'm going to need to buy a whole pack of cheese. And the pack of cheese, I already forgot, these numbers. I need to write this out. We started with 15 slices. Attempt to do some math. Our pack of cheese had 8 slices of cheese. Just realize that we're talking about slices is the same in both. That's a little confusing. But they're orange versus purple, right? Bread versus cheese. Okay. How many sandwiches can I make?
8.
Oh, that's exactly what I wanted. 8. I can make 8 sandwiches. Why can I make 8 sandwiches? I have 8 slices of cheese. I need 1 slice of cheese per sandwich, so therefore I get 8 sandwiches. Okay? What did you just do in your head? You took slices of cheese over 1, and you converted that into sandwiches. Your slices of cheese, orange, to sandwiches right? How many slices of cheese per one sandwich? 1 and 1. What happens? The slices of cheese cancel and you get 8 sandwiches. Okay? But somebody balked. They're like, no, actually it isn't 8. It says 8 sandwiches. I get 8 sandwiches. I have 15 slices of my bread. Whoops, I'm starting to write 8 again. I want to convert that into my sandwiches, right? Slices of my bread into sandwiches. What's that conversion factor? 1 sandwich is 2 slices of bread. 15 divided by 2 is 7.5, if we really want to get fractional with it, which means how many sandwiches can I make? I can only make 7. Not 8. Ooh. Which means to figure this out, I had to run 2 calculations. I'm not adding the slices of cheese to the slices of bread. I'm saying how many sandwiches can I get with cheese? How many sandwiches can I get with bread? That's how it works. Okay? The slice was the count. What is our count in chemistry? There's 2 units you could use. Technically 3. Molecules, phenomenal unit. Yes, that is a counting unit. I can count the number of molecules. AMU is a mass. What else is a counting unit? Moles is a counting unit. It's the number of molecules. It's a counting unit. Grams is not a counting unit. That's a measurement. I'm using a device to weigh that. The counting, I'm using my eyes to see it. What's the other counting unit? Moles is really the important one. Atoms, we could look at atoms. Okay, typically we look at molecules, but the most important is moles. Sorry. See, this is why you pay attention. Okay, so moles is our most important. Why do we count moles instead of molecules?
Make it bigger. Make it larger.
Has to do with the magnitude. For me to count the number of molecules, I can't count them. Can I count the number of large sets of molecules? Yes. The same thing goes with a dozen. Okay? If I send you to the store to buy a dozen, what are you buying? One package of eggs. No, I wanted donuts. Okay? A dozen doesn't specify the thing, it specifies the count of whatever that thing was. Okay? A mole specifies the count of whatever that thing is. Okay? So you use it the same. Moles allows us to now look at a large group of things, and that large group is convenient because that gets the mass up to a value that we can actually measure. That's why we do it. Okay? So our slice was a counting unit. In chemistry, our counting unit is moles. That's our bottom line. We don't want to deal with molecules. You bring in molecules, you get Avogadro's number. We don't like that. Let's deal with moles. Okay? So we go back to our question. What unit did we do in the initial question? Did we do moles? No, we did grams. Why? Because even though moles is a counting unit, and it's better to count moles than it is to count molecules, we still can't freaking count. Okay? How are we going to figure out how much stuff we've got? That's where we're actually going to need a device to measure it. That device is a balance in the case of a solid, a graduated cylinder in the case of a liquid, the pressure in the case of a gas. Okay? Which means we're looking at gram unit. Well, how does that tie back to this? Okay? Well, let's say instead of 15 slices, I said 15 kilograms and 8 kilograms of cheese. How many sandwiches can I make? For those people going through and saying, well, it's still 7, what was the unit? It was slices. And slices was what measurement unit? A count. A count that came from our balanced chemical equation. What unit is kilograms? That's a measurement, not a count. Which means for 8 kilograms of cheese, how many slices is that? I genuinely don't know. Do you really think it's 1,000? Okay. I don't know. I have a good enough concept about kilograms. Yeah, American, whatever. Okay. I would need to be able to convert the grams to a count. Once I had the count, I could then convert to the number of sandwiches. Rewind all the way back to the initial question. If I start with 25 grams of ammonia, I want to know how much nitrogen oxide is produced, right? To do that conversion, I would have to use a chemical equation, but what is the measurement unit in the chemical equation? When that says for ammonia, for what ammonia? Molecules of ammonia. But you brought in molecules. Did we want molecules? No, what did we want? Moles of molecules. And now it's scaled up where I don't have to deal with Avogadro's number. Why is this a problem? That 4 moles allowing me to convert over to the product is not the same unit as I'm given. Which means what do I have to do? I got to convert some shit. Okay? And just like with the sandwiches, it's not just one conversion. I have to run 2 separate conversions for each of the reactants that I've been given. Shall we do one? Come on, eraser, work with me. Okay. So just like with the sandwiches, I'm going to pick one reagent to start with. What reagent do we want to start with? NH3. Lovely. I'm going to start with this. What am I trying to convert that NH3 into? NO. Cool. The substance. What's the measurement? Carefully reading our question, we want grams of NO. Okay. What was the given information I want to start with? I said I wanted to start with the NH3. Okay. I was actually given a direct number for the NH3, so we could go ahead and put that in. But that's going to be a bit challenging to put in, right? Should I put grams of NH3 on top, or should I put it on the bottom? How do I decide? What was the deciding factor that allowed me to tell me where to put it? What was the question we ask every time we bring in a new thing?
If the answer is in grams.
We look to what I want. What I want is grams of nitrogen oxide. Where do I want that? In the numerator. I look at my given information. It doesn't one-for-one match, but it gets pretty close. It gives me grams. Where did I want the grams to appear? If I want it to appear in the numerator, where should it appear in my work? In the numerator. I now have a reason to explain why I'm placing it where I want to place it. I already forgot the number, 25. And now our fun begins. What's in the denominator? 1, because that was my singular piece of given information. And I now decide, does grams of NH3 equal grams of NO? Nope. What's different? I understand where you're going by saying missing the oxygen. I would take a larger step back from it. Is it the same substance? No. So what do we have to do? We need to do a substance conversion. I need to convert NH3 into NO. Where do I want the NH3 to appear? In the denominator. Why? So it cancels out. What do I want to appear in the numerator? NO. Right? And now we've got an interesting statement because someone actually floated out grams of NO, saying you want to include the measurement. Okay, so we could try and do that. We'll start with that for the moment. We should have grams of each of those, right? Ideal scenario, that works out perfectly. Does the conversion factor between substances exist in units of grams? Where does a conversion factor to change substances exist? Molar mass. Molar mass is moles related to mass. Grams and moles. Is this grams and moles? Nope, it's grams and grams. Where does the unit or conversion factor exist to change substances? How did I change bread into a sandwich? Mole ratio is the proper word, but I want to know where it's coming from. How do I figure out how to convert bread into a sandwich? What did I need?
Cheese.
I just take cheese and bread.
You need a recipe.
Thank you. I need a recipe for how to build that. What's the recipe in chemistry? The balanced chemical equation. So cool, I could go back up to the balanced chemical equation. There's coefficients in front. Just like if we were to go through and make our bread recipe, we could put 2 and then a picture of the bread and 1 next to the slice of cheese. That's the coefficients in front. It's the count. Okay? Operative word, it's the count. What is the unit you're trying to convert? Grams. Is grams a count? No. It's a measurement of mass, which means the balanced chemical equation does not give you the conversion between grams. What does it give you? What's the count? What's our unit for our count? One option, you said at the end of it, molecules. Did we say we liked counting molecules? No. What did we like counting instead? Moles. This conversion factor comes from the balanced chemical equation. And if we want to talk about, I hate chemistry, the only part of this process that is chemistry is that conversion. That's it. The rest of it is nonsense. Blame the physicists, blame the mathematicians. The only thing that's chemistry is that balanced chemical equation and coming up with that conversion factor. That is it. Where do I get the numbers to associate with that? That's the coefficients in front. So what number shows up with the moles of NO? 4. What number shows up with the NH3? In this case, you get lucky because they're the same. Okay? Cool. Did we solve our problem? No. In fact, we actually made it a whole hell of a lot worse, didn't we? Okay? Instead of getting rid of grams and bringing in grams, we didn't bring in grams and we didn't get rid of grams. Well, crap. Does that mean we failed? No, it just means there's more work to be done. Okay? So what do you want to do? Be done. You can't be done. Not yet. 5 minutes. What do you want to do? Okay. I heard moles to grams. I'm going to be confused by that because I don't know what moles you want to deal with. So again, what I would say is pick your focus. What are you trying to do? What do you want to do here? Because there's 4 things that we technically need to do. We need grams of NO, because that's not in our expression. We need to get rid of grams of NH3, because I don't want that in my answer. I need to get rid of moles of NO. I don't want that in my answer. I need to get rid of moles of NH3. There's 4 things that I have to go through and do. Which of those 4 things do you want to target? Moles of NH3. Okay, and for people being, well, why did you start with that? Because she said it. It doesn't matter. You pick one and you run with it. I want to get rid of the moles of NH3. That unit must cancel. Do I know the moles of NH3? Do I know the moles of NH3? We go back to the given information. Do I have a number next to the unit of moles of NH3? 4 is not a bad idea, but that 4 is found in the balanced chemical equation. And the problem with the balanced chemical equation is that 4 is tied to the 4NO. It's not an absolute value of 4. It's saying I need 4 to make this. It's a tied unit. In this case, there's no tied unit. It's floating. It's on its own. Do I know just the raw number of moles? It's not stated. I could bring in the moles of NH3 and relate it to the moles of NO, but then that undoes that conversion. That's not powerful. That's not useful. What do you want to relate it to? You want to relate it to the grams of NH3. Why do you want to do that? Oh, you're looking at 2 birds with 1 stone. That would be a really awesome trick if you could pull that one off. So now the question becomes, does that conversion factor exist? Yeah. Where does that conversion factor exist? That's off the periodic table. That's the mass, the molar mass on our periodic table. Nitrogen weighs 14.01 plus hydrogen weighs 1.01. Okay? Plus 1.01 plus 1.01, and we would get a magic number of 0.4. Okay? 17.04 what? Grams per mole. It's the molar mass. That's the point. So where does the 17.04 show up? Next to the grams. People are sick of me yelling. Okay. So cool, lovely. Did you get your answer? No. Okay, what do you got to do? You don't like moles of NO, so kill the moles of NO. How do you get rid of the moles of NO? Do I know the moles of NO? No. Okay. So I got to convert the moles of NO to something. What do I want to convert them to? Why do I want to convert them to grams of NO? Because that's what I want. That would be awesome. 2 birds, 1 stone. Get rid of 1, bring another one in. Hell yeah. Where's that conversion factor found? Periodic table. Oh, I just did that. It's 17.04, right? No, because the substance has changed. It's now nitrogen, 14.01, and oxygen, which should be a flat 16. Which gets me 20.01? 30.01? It's always that 10. I always miss it by 10. Okay? That was, again, our mass number, which means that 30.01 goes where? In the numerator. Nah, you got tricked. It goes with grams. The grams appears in the numerator. That is the only reason you can place it up there. What happens? Grams of NO... Whoops, I didn't want to cancel that. That was my answer. Moles of NO cancel. Now what do I have? The grams of NO, which means I can now punch it into the calculator and it gives me a number, and it means I've just solved for the number of sandwiches based off of bread. Now what do I have to do? Now I have to check out the cheese. Okay? What? Were you mouthing at me? Yeah! Yeah, all that work and all we got was halfway done. Yeah. This is why you should get used to this process so that it isn't all that work. It's there's the number. And you can now cancel those units and come up with that number very, very quickly. Okay? What I'm going to do is erase that bottom work for you. For you is not the right word. Erase that bottom work so that I can slide in the other option. We wanted grams of NO, except this time we were going to start with our O2. What was the O2? 45.0 grams of O2 over 1. What's going to happen? I really, really like, you don't have to agree with me, but I like going with that mole conversion. Recognize I'm converting the substance. Moles of NO over O2. Believe the NO was 4 and the moles of oxygen was 5. Okay, where am I? We'll deal with the NO. We'll show that we can swap up that order around. I want to cancel my moles of NO and bring in grams. That would be 30.01 grams is 1 mole. I'm now starting to cancel things. I want to get rid of my grams of O2, and I want my moles of O2 to appear in the numerator. Go to my periodic table, and I would say 16, except 16 is only for 1 oxygen. I have 2, which means this is 32, technically 0.0, I guess, if we wanted to get into it. If we look at our calculation, the grams of O2 cancel. The moles of O2 cancel. What unit would I have? Grams of NO. Now I can punch it into the calculator. See? That was fast. That one only took like 2 minutes. Okay? As opposed to the 10 minutes for the first one. We now have 2 numbers. What do we do with those 2 numbers? We compare them. Good. Whichever number is smaller is our answer. Okay? Because that means we've run out of that reagent and we can't make any more. So we pick the smaller number to be the most we could produce. You now have the work set up to be able to deal with entering that into the calculator. You still have to enter the calculator, pick your smaller number, and then enter that into what is this thing? Active. Sig figs, it looks like 3 sig figs. You should make sure your answer comes out as 3 sig figs. Make sense? Okay. And be excited, you just solved one of the longest questions of our homework.